In this video, I'm going to go through exploration number 2, which talks about learning target 2.2.1 slope. If you have not yet done the Desmos exploration for this that's on Classroom, go do that first and then come back and go through some of this with me. So we have kind of two methods of calculating slope. There's one we have a graph and one we don't. So the method when we do have a graph is we want to count squares for rise over run. So counting rise over run, our rise is our up and down. So let's kind of draw a little line here. So rise is up and down over our run, which is left to right. So looking at this example, we're given a line. We want to pick 2 points on that line. They can be any 2 points. I would recommend doing even corners because it's very hard to get an accurate number unless you're counting full squares. So I'm going to pick this point. And I'm also going to go down, and this one's on a corner as well. I'm going to pick that point. So to count rise over run, basically we want to imagine we're walking from this place to this place, but I can only use like streets to get there. So I'm going to only be able to go up and down and left and right. I can't go diagonal. So the first thing I want to do is count rise. Rise always comes first. It's always on top. So to get from this dot to this one, our rising is really going to be going down, which is okay. It's just going to change whether it's positive or negative. So if I'm rising, I'm going to kind of count squares like this. So I'm going down 1, 2, 3 squares. And since I went down, it's -3. And I'm going to write that off to the side over here. Then I want to count my run. So I want to go over and I'm going to the right 1, 2 spaces. And if I'm going to the right, that is +2. So on the bottom, I have a +2. Now I want to look at my answer and see if I can simplify that at all. Well, -3 and 2 can't be divided by the same thing. And if I use a calculator to simplify this, I'll get -1.5. For slope, we really want to keep this as a fraction, so I'm going to leave this as -3/2, and that's my answer. So then what happens when we don't have a graph? Well, if we don't have a graph, we're usually trying to find it from some given points. And so our general method is to use the slope formula. And so the formula is just something that you'll need to know. Most of you probably remember it from middle school. So our slope formula is m equals, and then I'm going to actually write this. I'm sorry if my handwriting is sloppy, but m equals y2 minus y1 over x2 minus x1. So one of the biggest mistakes students make is that they flip what goes on top and what goes on bottom. The way that I remember that is for our graph, it's rise over run. Well, rise is on top. Over here, our y's are on top, and rise and y's rhyme. So I remember that the y's are always going to be on top because they are in the rise spot. So what this means is that we're basically taking our two y values and subtracting them, and then dividing by our two x values when we subtract them. So let's do an example. I'm going to label these points. That should be your first step every time. So I kind of write them above the points, but you can write them below. I've seen that as well. So every point is x comma y. Our first point, I'm just going to label x1, y1. And then our second point, we're going to label x2, y2. So it's helpful to have these labeled because now I can just plug them into the formula, and I don't really have to second guess myself at all on where things should go. So I have m equals, and then I have y2, which is -9. And then I have minus y1, which is -6, over x2, which is -2, minus x1, which is 4. And so now I just want to simplify this once I have this all plugged in. So -9 minus -6. Well, minus a negative turns into a plus. So I'm going to quick change that. So it says -9 plus 6. And so that'll give me -3 on top. Over. And then -2 minus 4 gives me -6 on bottom. And so now I want to look and see if this can be simplified at all. So if I look at -3 over 6, well, -3 and -6 can both be divided by -3. So if I divide the top by -3, I get 1. If I divide the bottom by -3, I get 2. So this simplifies to 1/2. And that's my slope. So that there's another example in your packet of finding slope from a graph and the points. I'm going to kind of go through them, but not all the way. So again, for a graph, we just want to find 2 points that are on corners. I would say we have one here and we have one here. And so as I'm counting my rise and my run, I would count up and then over and see what I get for my slope. And with the points, remember it's super helpful to label these right away. So I have x1 and y1, and then I have x2 and y2. And then I can plug them into my formula and simplify. If you try this problem, you should get an answer of 4 for your slope. So why don't you give that a try and see if you get that answer. It's worth noting over here as well, if you count, you should get an answer of 4/3. So make sure you get these 2 as your answers when you try these problems. And last but not least, we want to put this all together. So we want to make sure that we can find all of the characteristics for any linear function. So the first thing we're going to want to know is this line increasing or decreasing? Well, as I read left to right, I can see that this line is going down. So this is a decreasing line. Then I want to count my slope. So I'm given a graph. I see I have an even corner here and one here. So if I count my slope, my rise is down 1, 2, 3, 4, 5. So down is negative. And then my run is over to the right, 1, 2, 3. And to the right is +3. So my slope will be -5/3. I can't simplify that at all, and that is fine. One thing I do want to note is that your slope and whether it's increasing or decreasing should always match. So if my line is decreasing, I know my slope needs to be negative. If my line is increasing, I know my slope needs to be positive. So kind of keep an eye out for that as you start practicing this. All right, and then our x-intercepts, we want to look for where this crosses the x-axis. So if I look, this blue line crosses right about here. It looks like it's just past the halfway point between 0 and 1. So my x-intercept, I want to write as a point. So let's do 0.6 comma 0. If it's a decimal like that, there's a few answers we would probably accept. So 0.6, 0.7, anything around there. Y-intercept, similar thing, but where it crosses the y-axis, which is right here. And that point is 0, comma 1. Knowing these 4 things is going to be crucial for you to be able to be successful on the test. So make sure you have an understanding of counting slope, both with and without a graph, as well as putting all those characteristics together into one problem.